this video, I'm going to show you how to connect WAGO PFC200 as a Modbus client to a WAGO Modbus TCP remote I/O. So we start off with the project. Select the 8212 as your target. And then you can scan the network, or if you know your IP address, you can type it in that box right there and press enter. Scan and find by PFC200. Click OK and it's discovered. If you want to add your K-bus IO modules to the K-bus, then you can come and scan for devices. And then here are the IOs that I have currently on with my controller, and I can copy all to the project. And then here, I'm going to add my Modbus. First of all, I'm going to add an Ethernet. Click on the Ethernet, and the menu changes. Now I'm going to select Modbus TCP client, so I'm setting up my controller as the client or the master. And then I click on the client again, and I select the Modbus server. So here you can also change the name. It's going to be Modbus 362 coupler. Close. So double click on the Ethernet and open up the menu, and I'm going to browse. Select the port that I'm going to use to talk Modbus. So my coupler, my remote I/O is on 1 dot network. So select BR0. If you don't see any IP address here, that means you need to go and discover your hardware first, like in here. You can select the BR0 or BR1 if you have the ports separated like I did. That's pretty much it with the Ethernet. Click on the client. And on the client, you have your response time now. That's pretty much it. As far as the configuration goes, you can choose to click enable auto reconnect or disable. Even if it's disabled, like here, if you lose the COM and then once you reestablish it, then the Modbus will continue to run after it's been established. So it's not necessarily critical to enable that. The rest of the settings, basically, it's going to be on this server device, your remote I/O. So you're going to enter in the IP address of the remote. Response time 1 second, 4502. And then now you have to basically create a channel. So your Modbus channel, basically Modbus addresses that you want to read or write to. So in this case, click on add. And with our WAGO Modbus couplers, if you go to the web-based management by typing the IP address of the coupler, and then you come down to Modbus mapping, then it shows you all the IOs modules that are on the coupler. So right now I have 10 IOs. 4XX, these are digital inputs, 5XX are digital output. And I have analogs and so forth down here. If you receive these XX, most likely those are digital modules. There's just not enough memory in them to provide entire full part number. So keep that in mind. And then, of course, If you want to read it as a register, you see that the first digital input starts at register 12. That's because on the coupler, analogs gets mapped first. So here's first analog from left to right, address first, and then 0 and 1. And then the next analog is 2 to 5, and so forth. And then the digitals come after the last analog input module. So then that's why it starts at 12. These are 8 channels each to make up one register. And if you want to write to the coils, so you would, read coil or write coil, then the address starts at 0. And of course, you can't write coils to the analog. So you can definitely use this information to build out your Modbus mapping here. So I can either do color inputs, the entire input register, starting from 0 to 13. If we go back to the mapping here, the address starts from 0. WAGO is 0 base. Keep that in mind. Most of the HMI and whatnot are base 1. That offset. So 0 through 12, so that's 13 registers. So here I set up, I'm going to read 13 registers, and if I get disconnected, whatever, then I'm going to set the values to 0. So then once you create it, and you can also create for the outputs as well. So here I have the digital out and one analog output. So again, you see that analog output gets mapped first, and then the digital. And these are the write only address and the read and write address. And then if I go back to Modbus, you see I can set up color outputs, right? Register function code 16, length of 3, and just verify 0, 1, 2, 3 registers. So once you have a channel created, then you go down to the IO mapping. Now it creates an address for those channels that you created. So here's the 13 registers of inputs, and then there's 3 registers of outputs that I created. So you can start mapping them. So let's say the first module I have is a 475. Next is channel 2, and so on. And then you can start mapping them. She'll map them, then global variable, and you can find them by pulling up the input assistant. You can press F2 key as well, and then it's going to be under IO config global mapping. You can select that into your code, and check to make sure that we have the connection. You can go online. Yes. And then you see that next to Ethernet and then Modbus client and also the server, you have these green circles. That means they're all good. You have the connection, and you see the raw value, reading the raw value from the channel, first channel on the 475 module. Now, if you want to set up a Modbus server, so now you're setting up the controller as a server device instead of a client. Go ahead and add. We already added the Ethernet. So here, select Ethernet. And this time, instead of the client, select Modbus server. And in the Modbus server device, you're going to, create how many holding registers and input registers, and also how many coils and discrete inputs you want. So I believe maximum registers you can do is 496. I would keep it short. I'll do 10 and 10. 10 registers of each as well. And you could also select the starting address. So here, they're all by default set to 0. And there are more other options. There's a writable option, which then it makes these two in the same memory area. So both the HMI typically would be the client can write to it, and then PLC can write to it. But be careful because you don't know who's writing to it, and they can easily overwrite each other. So I like to keep them separate. Then once you create this, then you can come here to IO mapping. Here are the 10 registers, holding registers, 10 input registers, 10 coils. And these are byte-wise, so 8 bits, plus 2 more, makes it 10. Same thing with the discrete inputs. And same thing with the Modbus client. Holding register is where the HMI can write to, and then the input registers HMI only has the read access. Same thing with the coils. Declare it up here as a byte, or you can create down here a bit. And again, this is HMI writing to bit 1. HMI can only read this area, discrete input area. HMI can only read it. Coils, HMI can write it, to it. Input registers, HMI can only have read access. And then holding registers, HMI has the write access. And then just like the client setup, you come here and all those variables are again declared, mapped under IO config global mapping. And then select them right into the code. Just as a quick example here, you see that client on the controller is running and it's communicating to the server, remote IO, and it's getting the values. But now the server has a error, a value of 0. And then you double click, and of course, status, this is not running. That's because I don't have a master hooked up to it on the client. In this case, I'm just going to cheat a little bit and hit the bot scan 32. I only have length of 10, so length of 100 will give me the error here. So switch that to 10. Um, on the coil, which doesn't help here, but in holding registers I can write too. Change this to integer. And you can see that as soon as I made the connection with the Moscan 32, now everything is green. I wrote in a value of 1, 2, 3, 4, and now you see that value. So that's it. Fairly easy and simple. I hope you enjoyed the video.